All right, so I just want to be clear. I'm not going to be going from start to finish making this discovery layer with these tools right now. Very close to it. I'll leave that as an exercise for the viewer. One of the things I'm doing is I'm running reveal.js for the presentation. I'm multiplexing for no good reason, because you can see this, and the folks at home can see this. But if you want to try it out, go to bit.ly/JYAccess, and it should update as I go through it. So if someone could just give a shout if it moves when I move it, I think that would be kind of cool. So I'm using the term discovery layer for lack of a better term. So really what I want to show is how to use off-the-shelf tools and scripts that I have found, not created, but found and modified in typical librarian fashion to get access to your data. I'm primarily interested in MARC data. So we have a turnkey solution. We don't have the direct access to our bibliographic content, and sometimes we want that access to do some fun things with, to mash it up, to play with, or to give out to student developers, to community members, the idea of open library data. So this is a good way of doing it. A lot of folks have EDS and some other discovery services with an API. Sometimes you don't want to give out the authentication information just to the average folks for that sort of thing, or maybe it's a little difficult to understand the API. This is an easy way of getting in there, getting your content in there, and getting some good access into what you have. So like I said, these are tools that I found. If you go to my GitHub, there's a sort of a step-by-step on how to do this. All right, it worked. Thank you. So the problem, I think it's a pretty common situation. You have some MARC, you want to do something, and you're not a programmer or a sysadmin. What do you do? MARC, for a 50-year-old data standard, designed to be read by, stored on magnetic tape, it isn't really user-friendly. The giant 2.5 gig binary file. You don't just VI a MARC dump and poke around in it. So over the years, I've used and I've seen others use these convoluted ways of getting this data out there. Screen scraping. At one point, we were actually dumping our tape backups into a MySQL database and creating an API on top. And this is, I think, a much more elegant solution. All right, so I'm using these 4 things. I'm using Python. That's a script to get everything from the MARC into CouchDB. CouchDB is and I'll get into the details as we go through. CouchDB is a NoSQL database. Elasticsearch is the indexer. And then I'm using jQuery and Bootstrap, simple Ajax, JavaScript, and CSS to display the content. And I think it's worth noting that there's no intermediate programming layer, so no PHP or Ruby or whatever in between. I'm just hitting the API directly, so not having to worry about that programming in there beyond the JavaScript, of course. All right, so the Python script I'm using is linked there. It's DCAG. It's using PyMarc, which makes things really simple to get the content in. Takes a MARC data dump, which you can use your own if you have access to that. If not, Internet Archive has a ton of various open data dumps as well. So running this script sends it as over to CouchDB as JSON, and on a relatively newish desktop computer, you're running about 1,000 records in about 8 seconds. I did 350,000 for this set of example. It's the majority of the Brock library data dump, bibliographic data, all using JSON puts. And this is the code. So I've mapped out some of the subjects that I'm interested in. I'm not interested at all in round-tripping this. So I don't intend to have marked fields on the other end. I'm just trying to get access to the data to play with, and so I'm just calling him whatever I want on the right-hand side, knowing that I'm doing this as a quick and dirty way of getting access to the content. All right. The actual code itself is pretty concise. It's just using the PyMark and running through all the records, and sending it over as JSON into to Couch. So saving into the database. All right. Well, what is Couch? Couch is a NoSQL database, relatively new, compared to the MySQL, Postgres kind of databases. It's got a built-in web server that provides its own API. So, I mean, really, if all you need is an API into your data, you're not worried about the front end, and you're comfortable using MapReduce. I'll talk about that in a sec. Then you really don't need any of the extra stuff. I mean, you can, step one, import into CouchDB, drop the microphone, leave the stage. It's got a built-in Restful Api. All the data's in JSON. JavaScript is the query language. CouchDB can cluster and replicate, and Couch isn't alone in this. There are a lot of other similar databases, MongoDB, Redis. Oracle has an NoSQL database. The clustering replication is actually really good and robust and real-time. And real-time, like seconds, not 15 minutes real-time. It's got built-in versioning. Anytime a record is saved, it creates a new version of that same record, which is great that that's built in. And it uses MapReduce for the views. And I'm having a difficult time wrapping my head around that, to be honest. So what I decided to do is just to run it all through Elasticsearch to give me to use the search interface. What I think is really cool about CouchDB, and that's maybe my next stage with this project, is you can do Couch apps. So CouchDB has its own web server, so you can actually build the application within the Couch environment, which means that and it's all developed you can develop in JavaScript and then push your JavaScript to Couch, and everything lives in the same environment, which is cool when you're doing the replication. So you can replicate not only your data across multiple Couch instances, but you can replicate the actual application as well, which I haven't tried out. If you just go to Couch Apps or Google Couch Apps, there's how to do it. The documentation is not quite all that extensive. So, like I said, I'm using Elasticsearch for no better reason than Elasticsearch has what's called a river. So there's Couch and there's Elasticsearch. You point Elasticsearch at Couch, and as you add, delete, make changes in Couch, it updates the search index in real time. So I'm not sure if that's something that's in Solr. It's all based on, Elasticsearch is based on Lucene, as is Solr, so maybe somebody knows. But the river thing, the real-time back and forth sharing of information or pushing is really quite cool. It also has a built-in RESTful API. I can show actually a couple of these things. So this is what the Elasticsearch API looks like doing a search for Brock. That's live data. I did manage to bork the whole thing this morning before lunch. So I did manage to get it back. So it's actually just completed re-indexing. So just a JSON API for that data. And sorry, while I'm at it, if anyone wants to see the couch interface, one of the reasons going back a step, I like couch is it's got a futon, which is the interface. Yeah, I know. And the couch tagline is relax. And the guy up there. This morning wasn't all that relaxing when I borked the whole thing. So you can see it's 211 megs for 350,000 some records. This is what you can actually get in there and see the data. These are the IDs that show on the main page. Gives the information that's been pulled in. Because it's Ajax and a front end, you can actually make the edit just by double-clicking in the web interface and change the data. Save the document back, which then gets pushed to Elasticsearch via the river, and off you go. Elasticsearch also has clustering and push replication. I by no means am an Elasticsearch expert, but I know enough to make a mess of things, and I know enough to get the stuff into Couch and index from Elasticsearch and into the last stage, which is using a tool that I've forked from Facet View, which uses Elasticsearch's API and means you don't need any server-side programming or an additional web server. So you don't need a traditional LAMP stack, or you don't necessarily have to bug your sysadmin to spool up a web server for you. You just hit that. You hit Elasticsearch's API via the Facet View code. So this is just running locally, no web server, and you pop in your content, you search, and there you go. So this is so this is just styled with Bootstrap, jQuery's grabbing the data. The faceting comes out of the box with Elasticsearch. This is still, this out of me screwing it up this morning, it isn't actually working properly. Can anyone tell me what's not working about that? It's single terms. It's not supposed to be single terms. It's supposed to be, yeah, so everything's, and it's really noticeable in the author field. So I did manage to screw up the faceting. So J is number 1. So that part didn't work for me this morning, but it should, maybe for you. And if you do want to see how that works, the facets are there, and you can start drilling down into. It's all pulling in real time out of the API. There's no server-side programming, and as a very basic proof of concept, how to get your data and how to play with it, how to maybe leverage this into something else. I mean, you could take this in any direction you want. You could you could start pulling in other content. The Python scripts I'm using the Mark, the Mark II Python, but the same package has scripts for OAI to Python to Couch. OAI to Couch and DC to Couch as well. So you can start. Oh, sorry. You can pull in content as well. I'm out of time, but I just wanted to point out 2 limitations. Well, I guess I showed the first is the faceting can be a bit tricky, and the other gotcha I have is when I told my sysadmins that I was playing with Couch, they brought this to my attention, and I think that's probably a good way to leave it.
Can you read it?
I suppose, yes. So how do I create a database? It's not a database, it's a key value store. Okay, it's not a database. How do I query it? You write a distributed map reduce function in Erlang. Did you just tell me to go fuck myself? I believe I did, Bob.